Welcome to Season 2 of Factory Forward, the podcast where we explore the cutting edge of manufacturing and industrial innovation. In today's episode, we're joined by Shiv Trisal, a global leader in manufacturing analytics and digital transformation. As the Global Manufacturing, Transportation, and Energy GTM at Databricks, Shiv helps enterprises harness the power of AI and data for a competitive edge. With extensive leadership experience at Raytheon, PwC, and EY, Shiv brings unparalleled insights into smart manufacturing, industrial data strategies, and how AI is reshaping the manufacturing landscape. Get ready for practical strategies, compelling case studies, and a forward-looking discussion on the future of industrial AI. Now, meet your host, Zishan Zia.
Hi everyone. Today on Factory Forward, we are joined by Shiv Trisal, a seasoned leader in manufacturing, industrial analytics, and digital transformation. As Global Manufacturing GTM Lead at Databricks, he helps enterprises leverage AI and data for a competitive advantage. With past leadership roles at Raytheon, PwC, and EY, Shiv brings deep expertise in smart manufacturing and industrial innovation. Welcome to the show, Shiv.
Thank you, Zishan. Thanks for having me on the podcast.
Yeah. Shiv, let me start by asking what what drove you into manufacturing and the industries you're in right now? You have pretty broad experience. You have some incredibly amazing degrees. What brought you into manufacturing or applying AI and data analytics in manufacturing?
Yeah, it's a very deep question to begin with, but I think the answer is pretty simple. It's actually airplanes that motivated me to join this industry. So as young as I can remember, I grew up in New Delhi, and there was like an Air Force museum right there in central Delhi where there was a really popular fighter aircraft right outside that. And when I looked at that, it just like sparks flew in my head, like just something that just sparked an idea of me, liking airplanes, liking being on them. Eventually, when I was younger, I took my first flight. Those kind of things just like gravitated me towards aerospace and aviation. And then I was very lucky to fulfill this idea and a spark, and it turned into a career. Having worked in the aerospace industry at the time with United Technologies, later merged with Raytheon. And I was one of those guys. My career in AI was not so much driven by deep research. It was driven more by application, and it was also one of those situations where the leadership of the company kind of came to a crossroads with digital technologies. And the idea there was, hey, these airplanes are generating so much data, and what do we do? We see that data as super valuable and to our future growth, and how we serve customers, how we design products, how we launch new offerings. And that was, I was tapped on the shoulder to go figure it all out, and that's what led me down this path. And it's not a decision I've ever regretted in my life, taking a bet on this area of technology. And so I've always been one foot in the industrial world and one foot in the technology world.
Oh, no, fascinating. Uh, Shiv, obviously, I follow a lot of the content that you put out there. Uh, One of the topics that I'd love to hear your thoughts on are the myths that manufacturers have around AI. Manufacturers aren't essentially the most technology forward. So what's the biggest misconception that you hear from manufacturers about or around AI adoption?
Yeah, I think number one thing I hear a lot about is, I think there's a misconception in the industry that manufacturing is purely a function. So there's many of the industries, like yeah, many people in the industry that I talk to, and even technology vendors for that matter, who serve this industry, they have this perception of manufacturing being a function, not really an industry. which is all they think about is assets in the factory and producing things more efficiently. But the way that we work at Databricks, and at least my understanding of having been in that industry for a number of years, which I was very fortunate to do, people have to realize that manufacturing is an industry, not a function, right? So you design products, yes, you manufacture them, but then you also go distribute them, you go service them for a very long life cycle, and there's many different varied activities that need to come together for your customers to keep buying from you. And I think that's one of the things, understanding the potential of data, AI, or digital. It's not just as simple as, hey, I unlocked a bunch of factory data and a bunch of magic happened. What happens is industrial data or data of any form needs to be combined with other data sets in order for them to be really activated in these areas of where value is realized, whether it's on the design side, it's on the production side, it's on the service and support side, or even on the distribution side. So there's that big misconception, I think, has led people down strategies that are over-indexed on one thing versus trying to solve for a broader set of activities that need to come together for your company to really gain a bigger advantage relative to competition.
That makes sense. I hadn't thought of it that way. That's a really valuable insight. Kind of maybe in that same space of breaking data silos, what are the biggest challenges in making industrial data more actionable, and how can companies overcome them? Your experience.
Yeah. Yeah, I mean, number one, it's just from my perspective, this is a very dense, complex data set, right? And there is no doubt about it. So I think there's a statistic out there, which is the industry, I think this was from Morgan Stanley, the industry generates in excess, if the most amount of new data is being generated of any industry is in this industry, it's in manufacturing. A lot of people think it's in financial services or retail. In fact, the amount of new data generated every day or every year is about 2 times the size of the second largest industry, which is financial services. So if you think about it, right, there is no shortage of data, right? And I think one of the things that I keep hearing again and again from customers in many discussions is this, hey, you can either be a victim to the complexity of that data, or you can look at the drivers of that complexity and have some sort of a much more thoughtful approach to be able to create value from it. And oftentimes I see a lot of companies tend to say, hey, manufacturing or industrial data is extremely special, and it is, but at the same time, it needs to be brought to a standard where it can be combined with other data sets, right? And I think, to me, that's and especially in an era of AI where you want not just general purpose intelligence, which is trained on the entirety of the internet. It's You really want AI that can reason on your data. And if you can't bring your industrial data into the same foundation that is being used for your AI development, I think you're going to lose out in the long term. So a lot of times, companies buy these extremely highly specialized tools, and thinking that they've solved for the complexity of these data types, but at the same time, they're also unknowingly creating a silo sometimes, which is not intentional. But then, it kind of becomes locked away in this complex ecosystem where it's like Hotel California. You can check out anytime you like, but you can never leave, with respect to data. And I think that's the part that can hurt in the long run. And I think the solution to that really is, how do you build out an architecture and a thoughtful platform to be able to treat these data sets at the same foundation. And I think that's the golden unlock you can have in an era of AI, where you may not immediately know that this sensor reading is super important to me, Typically, what ends up happening is multiple sensors doing multiple things over time tend to become important. This is the importance of non-local features, particularly important in the industrial space. And also, your problem spaces tend to be undefined when you first start collecting data, right? You don't really know what you're solving for, but generally, yes, I'm trying to lower costs, I'm trying to improve the energy efficiency of my processes, or I'm trying to improve the yield or throughput of my sites. But you don't know this to the down to the T. Hey, this is the exact sensor readings I would need, and this is what I would be able to solve with it. So I think for a market and a landscape where you have very non-local features have tremendous value, and you have undefined problem spaces, and you have tremendous fragmentation in industrial and enterprise data. I think you need to be a lot more thoughtful about your architecture in how you're going to architect the AI systems of the future, which are so badly needed in an industry like ours.
That's really fascinating. Shiv, kind of in that same vein, uh, can you do you have any examples of companies who have actually turned data across these silos into revenue, or whether top line or bottom line, or cut costs? Do you have any examples there that you could be able you are able to share?
Yeah, I mean, the good thing about working with Databricks is we get to work with the most innovative companies on the planet, right? Now, people who are really taking data and AI and making it real, really bringing it to the physical world. So, I'll take a few examples, right? We talked about this distinction between manufacturing as an industry and as a function, right? So let's start with, how do I think of manufacturing as an industry? If you look at the example of John Deere, the work that they've done to take telemetry data from their connected agricultural equipment and really using predictive analytics to be able to come up with what they call expert alerts, which is take their domain expertise on how this equipment performs and how it doesn't perform or does not doesn't give the results and leads to downtime, and they're able to predict these failures way in advance. And the benefits of that is taking telemetry data, combining it with your field service and dealer infrastructure, because a lot of their equipment is maintained by their dealers because they are responsible for their ability to serve the life cycle of that equipment. And what they've done is they've been able to launch that service. And earlier, it would take, anytime there was a downtime alert in the field, it would only happen after the fact, right? So you would have somebody losing, access to their machine or the ability to carry on the job that they're looking to do in the agricultural industry or on farmland, and then they would have to go take it out to a shop by themselves, call the shop, make sure that there was some capacity there. So you can see this is not a very good experience, right? This is something that loses, as a result, that business or that individual loses time, they lose money, they have all this headache that they have to take on, and then they have to, pay for the repairs, right? So there's all the stuff and plus pay for the repair. So what they've done with this expert alert system is they're predicting these failures in advance. They're notifying dealers of these potential machine issues before they become critical and proactively dispatching support. So typically it used to take them 4 hours after the fact. Now it takes them, once they look at like what the expert alert system is saying, using telemetry data and combining it with all their historical records on the repair side, they're able to say, hey, let's dispatch this technician going to this general area much more proactively so that this entire issue can never lead to downtime in the first place. So you proactively dispatch technical support within the hour before this thing even becomes an issue. And that's where Deere has become a proactive service organization. So, it was not so much a factor of taking data from factories, but it was more about taking data from their products, combining it with other data sources, particularly in their aftermarket and dealer organization, to be able to position the right solution that maximizes the economic value for the customer. So I think that's a really I would say first class example of how you use data and AI and bring it to your customers and lead on innovation.
No, I absolutely love that. I've heard examples of predictive maintenance on shop floors, but this is the first time I've heard of an example of something much more dynamic where the product is actually already on the customer side. They're using it, these combine harvesters and so on, and something breaks down, and or before something can break down, you send somebody over to fix it. That's
Yeah.
really fascinating, and I
Yeah.
bet that's a game changer in that industry. Uh, Shiv, I think this is also something you've talked about, smart manufacturing at scale. How can typically manufacturers take this crawl, walk and run kind of an approach? How can manufacturers move beyond that one plant at a time approach to scale AI-driven improvements? Any
Yeah.
thoughts there?
Yeah, I this it's interesting. The one plant at a time approach is really challenging, and I think there's a lot of people, on the internet and social media these days. Everybody's a guru on digital transformation, and everybody talks about crawl, walk, run. I mean, it sounds right. Like it's like, hey, take baby steps before you become like Usain Bolt or something, right? Like, but the idea, like, I personally take a little bit of an like. I mean, it's good advice. Don't get me wrong. For people who are, maybe taking their first steps, makes sense to take smaller steps before and get some small wins before you go too big. But at the same time, those steps can be a little bit more intentional, right? Like and what do I mean by that? What I mean by that is, if you take only site specific problems, right? So if you have no two manufacturing sites are the same. In fact, no two production lines on a manufacturing site are the same. But at the same time, that doesn't mean like, so if you start prioritizing, right, like based on, hey, which site is got the biggest problems, then your entire strategy is indexed to that site, right? By definition, that would happen. But what we've seen companies do, that have done this particularly well, they kind of take this parallel approach, which is, yes, there are some site level issues that need to go get addressed. So a good example, is the company Corning, which we've worked with to deploy basically computer vision driven defect detection inside of their manufacturing sites. So they're taking all of this high resolution images that's coming from imaging systems that are taking high speed images of their products as they are getting manufactured, and then turns out computer vision models can, as you know this, Sishan, are better at identifying surface defects than relative to human beings even. So and they're really effective and really performant, and they don't really get tired, right? So that's just a reality of how do you take this very specific problem around product defects, manufacturing defects specifically, and take that product off the line before it ends up in the hands of customers. And so one way of looking at it is like, hey, let's go after a problem like that in quality, which makes a lot of sense, and that's where people are looking at, hey, let's go put this in one plant and then scale it. Once you have a framework for how do you want to solve this kind of a problem, then you build a pattern that can then scale to the rest of the organization. But at the same time, a lot of the people who I would give a lot of examples of customers who've seen, hey, what is a problem that is common across every different manufacturing process or site? And I think the example of what Michelin, the tire manufacturer, is doing is really insightful, right? So what they said was basically their thought in this situation is, and I agree with this to a large point, is manufacturing is not just asset intensive; it is also resource intensive. And one of the resources that it's most intensive for is energy. And at the end of the day, all manufacturing processes and sites consume a lot of energy, and energy is a lot of cost depending on where you are in the world. Some parts of the world have lower energy costs, say the US, versus if you operate plants in Europe, not the same story, right? And also has tremendous implications from a geopolitical perspective and just costs, right? Everything is going to the bottom line. So what they've done is they've implemented a solution built on Databricks, in which is to democratize the energy consumption information coming from thousands of meters. So think about all these meters that are collecting data around energy consumption. They're tagged back to specific manufacturing processes or sites. And then they've really taken billions of these data points that are coming in every month, enabling sort of, hey, this is your energy consumption last month, last year, looking and mapping it to specific processes, comparing it across different plants. So for example, why is this plant in Germany that's running the same manufacturing process consuming more energy than the plant in France, right? So that's something that, again, if you
Oh,
nobody
wow.
would have thought to
Yeah.
analyze this
Wow.
information, but when they did analyze this information, turns out the equipment in Germany had, a maintenance practice that needed to get corrected, so that the energy efficiency could be brought to the same level as the plant in France. So think about, like, this is net new insight that nobody would have seen or cared to look at,
Yeah.
if this data was not available to be combined with other data sets, and be able to create this kind of insight that helps them cut energy costs and also make us reasonable progress and accelerated progress towards their sustainability goals as per the Paris Climate Accord, which is 3%, in reduction in energy consumption across all of their factories, 70 or so around the world. So this is something, to me, is becoming more and more relevant, which is, don't just take site specific issues and make them the core of your strategy. Yes, never waste a good crisis, of course, but at the same time, you also have to look at what are certain problems that you see across. And I think this place of energy efficiency, decarbonization, and sustainability is certainly something that I see, applies to every site. And I think you can build, your strategy around that, and that's something that's extremely powerful.
I love that. Again, we've just been talking for 15 minutes and you've packed in more examples, more use cases than I'll hear at a whole conference. So I love that. Uh, Shiv, while we are on a roll, can you talk about any example? You talked about a supply chain example. You talked about something that's actually on the field. Can you talk about some similar example, or any kind of case study out of the engineering world as well,
Mm.
where AI is, or design, if you will, right? Where AI is also helping. Maybe if there's anything off the top of your head. Again, I'm really putting you on the spot here, where AI has
Yeah.
been valuable. Yeah.
Yeah, I think my perspective on on engineering and R&D is it's pretty straightforward. Like, I mean, it doesn't take a really smart person to figure out, the fact that all of data and AI, like, or digital technology for that matter, it's a huge tool to drive an order of magnitude improvement in the most skilled, costly, and innovative resources in the company, which is engineers, right? And that is just the reality of. And if you look at, I work with a lot of engineers, in my time in industry, and now even, I interact with a lot of engineers in Databricks, and they're much smarter people than I am. There is no doubt about that. But at the same time, how much of their time is actually used in value added work is a big question mark. And it's not for their own, it's not something that, people obviously, have, they want to add value, and they, but how much time are they actually spending in a 40-hour work week on real engineering work, right? I think that's the question you got to ask yourself. And I think, to me, generative AI has, if it is to be successful in this industry, a good barometer would be how much more hours in the day are engineers getting back in their day to be able to put to real engineering work. And I think that's an area where we're seeing a lot of traction. And one of the examples, and we've seen this in multiple semiconductor companies, which is, hey, we have all these knowledge bases, we have all these US patent office data, and we have, so anytime we have to come up with a new product, right, we have to do a set of tasks to be able to make that investment. Hey, do I have any existing configuration data? Do I have an understanding of, hey, do I have existing software that I have built out in other parts of the business? Where can I look at, these kind of products, that what can I use to really accelerate my time to market to this particular product innovation? Can I look at the patent data or invention disclosure data to be able to whether I should invest in this in the first place, or is this going to be a risky investment? All of that is like a search, right? Everything I've done when I used to manage teams, full of engineers, they would go run these queries and, come up with Excel files and like
Yeah.
all super laborious things. And I'm like, why are engineers doing that, right? Like that's not a good use of their time. So I think there's a study out there which says like, I think, like less than 50% or like 40% of their time is actually used for actual engineering work. The rest is just, like overhead, like kind of
Right.
tasks like this. So imagine if you could give them 10% of their time back, right? How much
Yeah.
faster would these companies innovate given, they're able to pull up these insights from inherently unstructured data, ask questions in natural language, get answers back. And that's something that makes them order of magnitude more productive. And we've seen examples of Corning, having built like an AI research assistant. A couple of different semiconductor companies are doing the same, which is indexing all of this information and then making it available to engineers, as they're building the next generation or of a old product, like basically a newer generation of a product that's existing, or even coming up with white space, a new product in a white space that they've not dealt
Yeah.
with before. So that's super interesting. And another area that I see a lot of traction in is especially the use of generative techniques to be able to look not just at language, but in multimodal spaces. So, for example, let's say you're trying to, let's say you're a jet engine manufacturer, in this case, Rolls-Royce. You are designing, you have a design change that you need to go do into your, let's say a particular engine to improve the performance or lower the fuel costs, or whatever the reasons for that may be. And then you end up doing like a simulation study, right? Like regardless of regulation, you'd end up doing a simulation study, but that simulation study is kind of expensive. It's lengthy. It's what are the and then you have to shortlist which candidates you take to that simulation study. So the ability for you to do that, is this exploration of the design space is better served through generative AI, right? So you can say, hey, what are the possible designs that meet these requirements that I have? And then do a quantified ranking of which ones are most likely to actually satisfy the design requirement, and then you can go run a simulation study on those candidates, right? And I think that's where a smarter workflow looks like for product development. And we see not just in aerospace, we see this applicable in a number of other industries, whether it's semiconductors, whether it is we've seen this quite a bit, how to go optimize for these kind of design spaces, or even understanding, design for manufacturability kind of studies, where you don't have full understanding of what your manufacturing setup would look like, but you want to have the best yield. And so you want to design for that, right? So there's a lot of simulations and generative techniques that can be applied to speed up the traditional simulation-driven workflow for developing these kind of insights. And we're seeing tremendous traction on that, and we're working with a few customers, like I said, both in aerospace and semiconductors and industrials, across the board. Just because the value of making engineers more productive, making your most costly, most innovative resource more order of magnitude more productive, just has tremendous benefits, not just for their customers, but even for their bottom line.
That's amazing. Again, amazing set of examples, and I really appreciate it. Shiv, in manufacturing, a lot of data from the shop floor naturally goes into, these digital systems called ERP or MES or PLM. There's a fair bit of overlap between them, and one of the leaders in that space being SAP. So how does Databricks integrate or partner with these kinds of solutions or platforms, and how is that changing the way that manufacturers integrate operational and market data?
Yeah, I mean, this is a great time to be asking this question because just last week, we announced a massive collaboration between SAP and Databricks, which is, a lot of the work that Databricks has done over the last, I would say, decade or so was to truly, bring data and AI capabilities and have the best functioning platform and product out there. And I think that's become a standard almost in every industry. The lakehouse architecture that was started was kind of driven out of here. And what we're seeing increasingly is this partnership with SAP is really valuable because now you can take SAP data, you can take non-SAP data, and you can bring it in one place to the same standard. And I think that's super valuable because that's been all the ways to get data out of these systems are so hard and so expensive and time consuming, and they break all the time. And that's not where customers want to spend their time. The customers want to spend their time on delivering the outcomes that you and I just discussed. So making the access to those data sets super simplified, super seamless, and lowering the bar for these kind of solutions to come in is super exciting. So we're excited about the SAP Databricks motion. What it means is, we're fundamentally customers are going to get the power of Databricks inside of their SAP analytics infrastructure. So super excited about that. And then also, customers, can bring in SAP and non-SAP data into what feels comfortable to them. Especially the Databricks customers, they can combine SAP and non-SAP data like they have worked, like they've been doing for years, and now they can do this in a much more effective way without having to add on a bunch of unnecessary tooling, which then adds cost and overhead and complexity, which nobody wants.
Love that. Shiv, kind of, we are approaching the end of our session. Uh, what's the next AI breakthrough in manufacturing? If again you've been exposed to such a wide and diverse array of use cases, where AI is being applied to manufacturing and these allied or nearby fields, areas. If you had to bet on one, maybe it's a tough one, but if you had to bet on one AI-powered transformation in manufacturing over the next 5 years, what would that be?
Yeah, that's a good one. I think the broad adoption of like data and AI capabilities for non-technical users. And this is the part that you know at the end of the day, you can have the most elegant data platform on the planet, but also create a situation where nobody uses it. And I think that would be in like ultimate boohoo
Yeah.
in terms of breakthrough. So you can do really pioneering work in AI, and nobody adopts all the benefits that we all know and believe about the technology. So I think to me the next chasm in AI truly is that needs to get crossed truly is this non-technical user adoption
Mm.
of AI systems. And I think we're starting to see that in the consumer world. I think in enterprise and industry, I think that's something that's yet to happen at scale. And I think why that would happen and why I believe this will happen is because if you look at today's environment, the industry, all the challenges, geopolitics, and securing access to raw materials, just the macroeconomic situation, the fundamental thing is the situations and the environment around you changes so quickly
Yeah.
that this legacy way of, hey, I can manage my business through or manage my department or manage my function or my activity just based on by creating reports to answer
Yeah.
every question. The reality is, people are gonna move away from that because the idea is you should be able to get real-time data, you should be able to get the latest information about your business, and people want to be able to get this in embedded into their daily lives at work. so that they can actually run better businesses or better functions or better activities. And I think that's why I believe this is only, we're only starting to see this now, thanks to the power of generative AI and large language models. Obviously, it started there, but I feel there's so much more that is coming through as a result of that. And I think the biggest area that I see it having the biggest impact is really crossing that chasm of adoption from non-technical users, and I think that's the part that's super exciting from
Yeah,
my perspective.
that's really insightful, and I'll completely agree. That makes a ton of sense. Shiv, thank you so much. This was incredibly helpful. And again, I don't think I've ever had a conversation or certainly podcast for that matter that was so packed with use cases and case studies and examples. I think anybody who listened to it is going to hear these half a dozen to a dozen case studies and really come out pretty educated about the value and the impact of AI and data and so on. Thank you so much, Shiv, for your time. I hope we can get together again soon at a future episode as well. But really appreciate you taking the time.
Yeah, thank you. I had a great time talking about this. Is, like I said, my one foot in industry, one foot in technology. So this is always a fascinating conversation. Thanks for having me on.
Thank you.
And that's a wrap on this powerhouse episode of Factory Forward. If you love this episode, share it with your network and keep the conversation going on social media using #FactoryForward. Until next time, keep challenging the status quo and striving for excellence. Thanks for joining us, and we'll catch you in the next episode of Factory Forward.